Yo, what's up? All right, so today is all about solving one-step equations. So it doesn't get easier than that because it's one-step equations. Now, when we do this, I'm going to ask a whole lot of questions of myself as we go through this. So we're going to solve one-step equations. The reason we start with this is because it's a very simple concept. It gets the ideas down as we go through. The reason it's a little bit easy is because there's not a ton of decisions to make, but it gets you the process down. So if you remember from my intro video, or if we talked in class, remember the laws are in effect. There are 4 of them, okay? We will show all steps. We will not skip. We will verify everything through a check. We will put our answers in set notation, and we will keep our equal signs vertically aligned. So I'm going to show you this whole process as we go through. So I'm going to make a real simple one here, and guys, I know everybody here can look at this and go, x is 3. I understand that. I want to make sure that we have the process down and understand what I expect. Okay. So the first thing is that you got to keep in mind they're not going to all be this easy. So our job here is to solve for x. So this is that whole grill thing I talked about. We put math together with a series of steps. This is telling you to add 4 to x. Of course, I can't do that. Why can't I do that? I don't know what x is. I can't add 4 to it. So what are we going to do? Well, we're going to go ahead and we're going to tear this math apart. We're going to tear that grill apart, which means we got to follow our order of operations backwards. Now, in this case, there's only one operation, so I don't have to follow my steps, but I'm going to keep referencing that. So what I'm going to do is I'm going to tear this math apart. I'm going to tear that plus 4 apart. So how do I undo that addition of 4? That's where those inverse operations come in. And in order to undo that addition of 4, I am going to subtract 4. Now, I'm sure as you've known for years now, is that an equation is a balance, okay? So if I add, subtract, multiply, or do anything to one side to keep my equation balanced, I must do that to the other side. And by other side, I mean the other side of the equal sign. This is that balance, or fulcrum, if you will. So we're going to subtract 4 from that side as well. This is me showing my steps. So then I'm going to come down here. Nothing happened to x, so it comes down. Adding 4 and subtracting 4, well, guess what? That's 0. That eliminates. I don't have to put anything down. My equal sign comes down. Notice vertical alignment. And 7 minus 4 is 3. So what happens right now is I have a solution. At least I think I have a solution. We are going to verify that solution through a 3-step check. And I know right now you can do a lot of this mentally, but we want to get the process down. So 3-step check, step 1 is to rewrite the initial equation, the original equation, go back to the beginning. I'm then going to substitute the value in that I think it is. I think 3 is what x is, so I put it in there. Notice my use of parentheses. Are they necessary here? No. Can they hurt me? No. It's like wearing a seatbelt. Then I can verify this, grab my calculator if I would like to, type it right in there. If you do not have your calculator, you can of course pull up Desmos. You're going to verify that that does indeed equal 7. When you get a true statement, that tells me, hey, that works out, it checks, I'm all good. The solution to my equation is 3. Got carried away with my 7 there. My solution is 3, and that's my answer. Notice I used a set notation bracket, okay? Hopefully that was pretty easy. Again, we're just getting the process down. Let's try another one. Let's throw some negatives in there because we love negatives. Let's put in negative 7 f equals, let's go with, 56. We'll make it fairly simple. So negative 7f equals 56. So basically what this is telling me is that negative 7 times f equals 56. It's a one-step equation, meaning there's only one mathematical operation in there. So what I'm going to do is I'm going to tear this math apart. I can't take negative 7 times f. I can't. I don't know what f is. So I'm going to tear that multiplication apart. How do we tear that apart? We use the inverse operation. So to get rid of that -7 being multiplied to f, I'm going to get rid of it by dividing. I'm going to show that with a division bar or a fraction bar. So I'm going to divide both sides by -7. This is me showing my work. Now, -7 times f and then being divided by -7, since multiplying and dividing are inverse operations, they will undo each other. That means all I have left over here is f. It's a one-step equation after all. 56 divided by -7 is indeed -8. So once again, I have a solution. I'm going to verify that through a three-step process. So -7f equals 56. That's my initial equation. I'm going to substitute in the value for f that I believe it is. I believe it is -8. I'm going to grab my calculator and punch that in, or I can do it in my head because it is pretty easy. -7 times -8 is indeed positive 56. That is a true statement. It checks out. That means that my solution is correct in -8, and I put it in a set of solution brackets. Hopefully that's going fairly simple. Let's do one more. Let's do, actually, I got an idea. Let's do 14 equals x minus 9. So now we have my equation on the other side, or my variable on the other side. This is one of those things that always bothers students. Get used to this. The stuff we do, everything can pop up wherever it wants to be. It's no big deal. It's no difference. We're just so used to seeing it on the left. Sometimes students freak out when it's on the right. The process is the same. Basically, I am subtracting 9 from x, and I'm getting 14. Problem is, I can't subtract 9 from x and don't know what x is. So what I'm going to do is I'm going to tear this math apart to figure out what x is. To tear the math apart, I have to undo what's being done there. What's being done there is that we were subtracting 9. To undo that, I do the inverse of subtracting 9, which is to add 9. And notice, I put that right underneath that subtraction. What I do to one side, I have to come over and do to the other side. So I have 14 plus 9. That, of course, is 23. And that's going to equal x. And subtracting 9 and adding 9, they are inverse operations. So they undo each other. I believe that 23 equals x. I will verify that through my three-step check system. I'm going to go ahead and substitute into my equation what I think x is. I'm going to grab my calculator. I'm going to type that in if you want to use it. I'm going to get 23 minus 9. Of course, that's going to give me 14. That's going to check out. I verify that that is indeed the solution. So I'll put it in a set of solution brackets. And there is my answer. Hopefully you find that pretty simple. I'm not going to go ahead and set up some examples for you to follow since we just did several. I do want to show you one other thing, and that is the situation like this. Let's use y this time. It's something like that. Now, when I look at that, that reads to me the opposite of y equals 4. So when I look at that, I'm like, whoa, 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 whoa. What does that mean? Keep in mind that anytime you have a variable, and whether there's a negative in front of it or nothing in front of it, it still has a coefficient, and it has a coefficient of 1. So regardless of whether it's the opposite of y or just y, I can always sneak a 1 in there, and I've changed nothing. The reason that's important here is it makes me realize what's truly going on. This is actually -1 times y. So the opposite of y actually means -1 times y. So that allows me to really see that attached to y is a -1 by multiplication. It's a coefficient. That means it's attached by multiplication. So that means I get rid of it by division. What I do to one side, got to do to the other. -1y divided by -1, well, guess what? Cancels out. I get y equals 4 divided by -1 is -4. So once again, I have a solution. I'm going to verify that that's correct by doing a three-step check. So rewriting the initial equation, now keep in mind, the original equation was just this. That's why I always go back to the original. I'm going to substitute in for y what I think it is. I think that y is -4. Notice that all of that -4 just went in there. That negative is still there because it was the opposite of y. So now it's the opposite of whatever I think y is. I think y is -4. Now, if you're looking at that going, whoa, 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 what is that? Don't fear. Punch it into your calculator. I can punch that in exactly as I see it. I'm hoping we can see that. Yeah, and then I'm going to press enter. Guess what? I got 4. So that means it did work out. That is correct. So my solution is -4. I've seen a lot of students use different colored pens and pencils as they're working through this, like I do, to show what's their step, what's their original equation, maybe something that you want to keep in mind. Please also notice, I can pretty much go down a vertical line and keep my parentheses in check. Not saying I have to have a ruler on it, but that line should not go like that, okay? It's a lot easier to read and keep your things in order, okay? So that's solving equations with a single step. Hopefully that was pretty easy, and I will talk to you later.